Hello and welcome to TGIK. All right, we already have some folks going on in the chat. So 2 weeks ago, I tried to do TGIK from home, and we had all sorts of problems with YouTube streaming. The audio was all messed up. So hopefully this is working. So I'd love to get some confirmation. Yay, it works. All right. So Sean is saying that it works. Thank you, Sean. So here's what I think happened last week, and this is my theory, and I'm like, low confidence because who the hell knows what happened, but I think 75% sure that we had a problem with YouTube. When you launch one of these live streams with YouTube, you have to go through like a preview stage where you can privately see the stream to make sure everything's good, and then you click from there to actually go through and start the stream. I was running late, and so I just like boom, 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 clicked through that stuff, so I wanted to go live without going through that preview stage, and I think maybe I transitioned too fast there. So I think we're set now. So okay, so for those who don't know, my name is Joe Beda. I'm the CTO of a startup called Heptio, and we're focusing on bringing Kubernetes to the enterprise across a whole bunch of different dimensions. And TGIK is a weekly, or at least we try and do weekly, hour and a half, 2 hour live stream where I dig into some interesting facet of Kubernetes, whether that be covering a core feature, an ancillary project. I did some stuff where I did a bunch of coding of a controller. So just try and dig deep into something, and hopefully along the way, I'll learn some stuff. You know, the folks watching will learn some stuff, and we'll have fun. So first I want to say hi to everybody. Let's see, so what do we have? So we have Suresh and Sean were on beforehand, so things are looking good there. Thank you for confirming that, guys. Fernando, awesome. Welcome. Let's see. Ibrahim, good to see you. Caleb from Hog Country. Soima Lamadi. Jesse in New York is done for the week, I can tell. That's why the more E's she puts at the end of my name, the more done for the week she is. Miguel, Eddie, good to see y'all. Eddie from Guatemala, awesome, welcome. So my plan this week is to start going into tools that look at, and I'm probably going to do like four episodes on this that look at a developer experience. So if you're a software developer and your deploy target is Kubernetes, why would you want to start integrating Kubernetes earlier into your development workflow? And then how do you go about doing that? And what are some of the tools and the techniques and the ways to sort of break this down and think about it? So that's the plan for today. Let's see, I want to say, let's see, more shout outs here. So let's see. So we have Federico from Gutenberg. I'm sure I'm freaking butchering it. I'm sorry. Miguel from Mexico. Good to see you. All right. But then one of the things that I like to do, I'm out of focus, as we start out here, is go over some what's been happening, new stuff that's been going on in the Kubernetes community, and just sort of give a few thoughts and a few pointers there on what's happening. So I'm going to go ahead and start with that. Let me switch to my screen here. And so the first thing I want to talk about is Kubernetes 1.10 is happening. There's a blog post. This was a couple of weeks ago, but we've been going through the betas. I don't think the release has happened yet. I haven't been tracking it super closely yet. But there's some good stuff going on in 1.10. But I think one of the things that you'll see is that things are slowing down a little bit. We're not seeing as many new features, as many changes. That's a good thing. I think for anybody who's building on top of this, there might be a few pet features that you really want to see. I know there's a few that I really want to see. But I think more than anything else, the biggest feature that everybody wants to see is for the thing to get more solid, for us to fix bugs, for us to simplify things and concentrate on some of the things that are not as shiny, but actually matter to folks who are using this thing in production. So I think, there's a good summary here. There's the change notes are coming along. The change log is coming along too, so you can look at that. The TL's bootstrap stuff, that stuff's been going on forever. I'm really happy to see that get there. This involves, this is one of the mechanisms that kubeadmin uses to boot up clusters, which is something that I've been working on for a while and that Heptio has been investing in. So it's really good to see that come along. Let's see. So locking down what access a node has. There was a security incident where, again, somebody didn't have all the options turned on, and there were a few things that snuck out, and they exposed some stuff to the outside world. And so it looks really bad. We're continuing to lock those things down and provide a lot of options around that. Client Go is continuing to make progress. And then the token request API is really interesting. This is something that some of the folks at Google have been working on. And what this is it allows you to use Kubernetes service account tokens for things other than Kubernetes. And so what this, people were already doing this, but it was kind of a dangerous thing to do. But the big reason why Google did this is so that you can associate a Kubernetes service account token with with a GCP service account. But this can be used for other things like authenticating to vaults and such. It still is not as good, in my opinion, as something that is based on certificates, because that lets you sort of cross-validate in a very generic way, and so you don't end up with this n-squared set of tokens that you have to manage. But it's still a very big step forward. So let's see some questions here. So Chris is across the hall. So yeah, thanks for watching, Chris. Let's see, we have Nadir from London. Marco's joining us. Awesome. And then Lamatti saying, how long do you think it will take for CSI to get to GA? Honestly, I don't know. I haven't been tracking a lot of the storage stuff very carefully. It's kind of like, it's one of those things where Kubernetes is just so big, it's almost impossible to keep track of everything. So I don't have anything concrete to actually share with you all there. Let's see. So so I'm reading this for the first time. So the storage stuff. So there's some metrics coming through. Some mount namespace propagation. This is actually. Let's see. So this is really interesting because it allows. I'm trying to remember the scenario around this, but I remember this actually being a real blocker. I think this is one of those things that's necessary for things like the kubelet running in a container itself. The local persistent storage stuff is in beta now, and that's continuing to make progress. That I think is by far, in my mind, the most exciting thing coming out of the storage stuff, because that lets folks use local disk without having to do a bunch of sort of bookkeeping outside of Kubernetes, or allow people to arbitrarily mount host volumes, which is essentially like YOLO from a security point of view. So yeah, super interesting stuff going on there. Oh, and then the dynamic kubelet configuration is really exciting too, because right now when you're configuring a cluster, you have to sort of manage the kubelet configuration, which is a bunch of command line flags that are usually stored in a systemd unit file. But then the rest of the cluster, by and large, or at least a lot of the rest of the cluster, can be managed through Kubernetes. And so this means that the kubelet itself now can get its flags, or at least the bulk of its flags and its configuration from the API server. So that's actually really interesting too. All right, so I'm not gonna spend too much time on this. The next thing I want to talk about, and I want to find time to dig into this, is Apache Spark on Kubernetes. Everybody's been asking about this. I'm not a Spark expert, but I know that a lot of work has gone into this. So this is super, super interesting, and I need to find some time to really understand what's going on here. So maybe after I do the series on developer tools, I'll have to take a look at that. All right, so, let's see, who's having, Eric, you're having problems? I'm sorry, sir. But it sounds like other folks are have a solid connection, so hopefully it's not on my end. All right, let's see, more stuff. So Jenkins X. So Jenkins is continuing to evolve, and so this is exciting also. Here, let me make this a little bit bigger. And so I think one of the things that's interesting about this is that a lot of the configurations from Jenkins is moving from stuff that you configure by logging into Jenkins and configuring it from the outside to something that can be discoverable using like a Jenkins file. And so it's a way to make Jenkins be more dynamic, more self-describing in terms of how things interact with Jenkins. And so also something I would love to look into. This, obviously is related to the developer flow, but I'm going to get into a little bit of detail on why I think might be different layers, different ways to break this stuff down. All right, and then Jessie has been working her butt off. And this definitely involves the developer workflow. But Jessie has been shaving yaks to be able to build containers on Kubernetes, right? And so here's the deal. So there's two ways right now that people typically build containers on Kubernetes. The first way is they essentially give some Kubernetes pod access to Docker directly. And so you sort of reach around the kubelet, reach around Docker, reach around all the protections of the container, and then talk to the Docker on the host. And as everybody knows, if you can talk to Docker, you pretty much have root on the host. And so you've essentially compromised the host. So you can do it that way. The other way to do it is that you can essentially run an unprivileged container or a privileged container and then do Docker and Docker, which means that you essentially run containers inside of a container and you host sort of your own private version of Docker. On one hand, that's slightly better because it plays with all the C groups and constraints that happen with Kubernetes, but it's still not safe. If you're running privileged containers, they're privileged for a reason. They can pretty much do whatever they want on the host. And so there's been a bunch of work about decomposing all of the things that go into building a container, whether it be running all the steps in something like a Docker file, how you can upload and download and crack open and make all the packages that get uploaded and downloaded to repositories. But the one thing that I don't think anybody has cracked is how do we actually have high fidelity usage of something like a Docker file and build that inside a container that doesn't have any special trust associated with it. And so there's been a ton of work going on with rootless containers, which means running containers as non-root. That's super, super interesting. But there was this one missing piece that Jessie worked with, which was having write access to proc. And so there's a ton of patches that Jessie's been working hard to push in. Hopefully those things will make their way through both with Docker/Moby and with Kubernetes. But as they make their way through, we should find ourselves in a situation where you can have a relatively untrusted user build containers on top of a cluster. And I want to be clear, this is not just people running on top of a cluster and sort of like how we do things by default, which is like you run as root, on a cluster. This is also running as non-root users on the Kubernetes cluster, which is a huge step forward in terms of the composability of stuff like this. So I'm really excited about that. Patches are still in flight. There's still work to be done, but I think it's exciting that Jessie has sort of blazed that trail, and so now we can see how to get here from here. All right, let's see. Walid from Saudi Arabia, nice to see you. Meg from Berlin, Anand from India. Man, the whole world. Yeah. And read Jessie's blog post. I'll put it in the notes. It's all came down to a bet over pizza with some of her coworkers, so that's funny. All right, so that's sort of like, I haven't done TGIK for a couple of weeks, but hopefully that's some of the exciting stuff that's happened over that. If there's anything else that you all want to talk about, maybe we can find some time at the end to dig into it. All right, so today I'm going to be digging into this project called Ksync, which allows you to synchronize files running on your local workstation machine with stuff that's running in a cluster. And this is a really useful building block, but I want to dig in a little bit in terms of why you might want to go ahead and do that. So here's sort of my outline here that I've been thinking about it. So the first thing here is that why would you want to run your development process on cluster, right? Because a lot of folks, the way they approach this problem is they write a bunch of stuff. They have their own development workflow. A lot of times that's integrated with like an IDE or an editor like VS Code. They have debuggers set up. They have their own ways of actually getting a fast sort of compile retry loop if you have a compiler or what have you. And so doing anything other than that is going to make things slower, right? Because if if you're doing a Node application or a Ruby application and you have everything set up so that when you hit save on your editor without even, clicking over to the browser, it reloads so you can see what's happening, why would you want to go ahead and change that? And the reality is that if all you're doing is a single application that can run locally on your machine and doesn't have a lot of external dependencies, there's not a lot of reasons to change things up. I wouldn't run on cluster just to run on cluster. So Soyman says, does it make sense? Integrate something like Ksync with meta control that enables us to do blue-green deployments. I don't think so. I think this particular tool is only for development. I don't think this is something that you'd want to use in production. So I'll get down to that. But I think the critical thing here is that a lot of times when you are developing, you're doing a small piece of a larger application. And sometimes that application is small enough that you can run it all on your local machine. So now you might do something like, hey, I'm going to run this thing in Minikube, and then my component that I'm working on, well, I'm not going to run it in Minikube. I'm going to actually run it outside, but I'll do enough port magic to be able to talk to the stuff that's running in Minikube. So you could do something like that, but then at some point you get to the point where the rest of the application that you're interacting with, it's not practical to be able to run that stuff all locally. And so now what you have is that you're doing sort of the tip of the iceberg or one piece of the iceberg. The rest of that iceberg is actually running in a cluster someplace and maybe is actually shared across a bunch of developers because maybe the infrastructure is like some big, machine learning model that, costs like, hundreds of gigabytes worth of RAM to actually run, right? You don't want to be running that stuff locally. You don't want to be running a personal version of that. And so now what you find is that it's difficult to really develop and test things out and really poke at things in isolation when you're starting to deal with a microservices type of application. And so you really want to develop in a way where you feel like you're running in an environment that's similar to how things are going to run in production. So that's the first reason. So again, if it ain't broke, don't fix it. But I think what we'll find is that as applications continue to develop, you find that that it's very difficult to actually really bring things together with keeping everything locally. The next reason is that if you have to develop one set of tooling for development and then a totally new set of tooling for how you deploy, there's opportunities to screw things up as you actually move from your development environment to your test environment to your production and then rolling it out across different geographies, perhaps, right? So, and a simple thing might be like, hey, we have a binary and we run it with a new command line flag. And so I'm doing local development. Maybe I have a little like make file thing where I do like make run and it's like I can up tab and everything's going fast. And so I introduce the requirement for this new flag. I add it to my make file and then boom, I'm done. Now I go ahead and I deploy this into production or into staging, and I forgot to actually duplicate that flag from my development setup to the staging production setup, right? So what you'll find is that every difference between development, testing, staging, and production, every change there will eventually lead to an outage or a problem or a hiccup in the process. And so I think that's one of the reasons why people want to unify this stuff as much as possible. So Thomas says, don't forget testing. It's frustrating to be required to run something through CI to run the test suites. Yeah, no, that's another great example, right? Is that ideally what we want to do is break this stuff down into composable pieces so that you can run the same thing that your CI system does locally. And then, you can start specializing and say, well, I want to run this stuff because that's the stuff that I know is going to impact by the work that I'm running. But I know that it's the same environment as what's going to happen when I send this to CI. If you find yourself in this position where you check some stuff into Git and then you watch CI and you're like, and then you do another check-in and you go, oops. And then you have to check in again, and then you have to have Git do it. And you have to have your CI system do it. And then you get to like, oops, number 12, right? That's a bad pattern, right? That's slowing you down. That's painful. That's not the ideal situation that you want to be in. Let's see. So So Soima says just that some of the services are just nano monolith services. I think there's a difference between having a dependency that you have to talk to be successful versus building sort of a distributed monolith. I think that, in my mind, that comes down to coupling and version skew. Right? If you can upgrade things without having to sort of like, if you find yourself doing releases across all 30 microservices and you do it in a sort of big bang type of way, then you're building, in my mind, a sort of a distributed monolith. But I don't think, at some point you take a dependency on the services that you're integrating with, right? Just like if you're developing an application that takes a hard dependency on S3, that's not you're not building a monolith with S3. You're taking a dependency, and that's part of your, and you have to factor that into your development process then also. Data to be preserved. So that's one of those things, is that you want to have data sets that are useful during testing. And then Lamatti, do you see this solely as a development tool, or do you see it working with existing CI workflows? I think you could use it a little bit of both. Now, Thomas, am I mistaken here? I think you are you involved with Ksync? I must be. Want to do a lot of research here before I do this stuff, unfortunately, and then I don't, and then hopefully. So Thomas, you obviously know a lot about this stuff. So you have the experience here. So you'll tell me when I screw up on stuff. But one of the other things I want to see here is as we look at how to break down these workflows, we want to find which pieces are reusable from development to deployment, and which pieces are maybe just development, and how can we start breaking some of this stuff down. And so, one of the gradations that I'd like to see split up is the way that you deploy stuff is different from, or how you describe your deployment is different from how you trigger that deployment. Right, so I would love to see when you describe your YAML or something that sort of turns into YAML eventually, or I'd love to see that be something that you can run locally yourself if you have the permissions to do it. But then you can also trigger that through something like a CD system, whether you're doing a GitOps type of thing where it's based on a Git hook, or maybe you're doing it as part of a Jenkins flow. Ideally, you want your automated systems to be using the same tool chain that you get access to locally. So that requires a level of factoring right there. Another level of factoring is thinking about the difference between continuous integration and deployment. Are there reasons why you want to split these things up instead of actually viewing them as one thing that's actually tightly coupled? Thinking about how do you reuse your configuration, your application configuration for development, also specialize it, maybe scale it down in some cases. So I think one of the things that we're working through right now is how do we actually define these different layers? Where can you mix and match? Where can we actually do some innovation around this stuff? All right, so that's that. So now when I start thinking about active development, so I'm ignoring CI/CD, I'm ignoring the deployment stuff, I'm ignoring how do you manage YAML. I think that's all really important stuff, but I think that's probably different components of this. As I think about this, I really think that there's three different approaches to smoothing over the development flow. And this means that I save something in my editor, and then I can actually interact with the result, right, running in a cluster or interacting with a cluster. And I think which of these three techniques you choose is really going to depend on some of your requirements around languages and tools that you're taking a dependency on. So the first one here is what I'm calling auto rebuild and deploy. And so Draft definitely falls into this category. I believe Scaffold does also. It may be more flexible than that. I haven't dug in super deeply. But the idea here is that you hit save in your editor, and then some process behind the scenes does essentially a Docker build, Docker push, and then rolls the deployment in Kubernetes. And so what that means is that you don't have to, it's very easy, one click or automatic based on the save of a file to actually go ahead and see your results running in the cluster. The downside to this is because you're going through the entire build process and push process, the latencies here will just naturally be longer because you're restarting the process, you're doing a real build along the way. Things that you want to think about with this is are you using a cloud build service? Google has one of these. That may be faster. There may be some caching there. They may be smarter about that. But that's a dependency, so you're not doing stuff locally. Now, the good thing is that you're producing stuff close to where you're going to use it if you're running everything on Google. So that means that you have fast pipes to actually move all the data around. You have to set up a container registry here. You can't do this stuff all locally. You actually have to have something for this to be able to push to so that you can pull from it. And then, so Tim says that Thomas wrote almost all of Ksync. All right, so Thomas is going to be our guide here. That's good. And I think there's another approach here, which is running on cluster and then syncing the file system. So this is probably most useful for dynamic languages that have auto reload on file changes already. So I'm thinking about things like Ruby and Node and Python. These things are really set up such that, if you change something on the file, automatically you can go ahead and reload it right away. So the file really becomes part of that. And people typically don't use interactive debuggers for these things, right? They typically debug by trying something out and looking to see what happens. Maybe a little bit of printf type of debugging going on there. But if you're doing something like C++ or Java, I think Go is kind of in the middle here, to be honest. If you're doing something like C++ or Java, a lot of times those builds end up being heavier. You want to get the incrementalism that you get with a local file system around this stuff. You also typically start using debuggers and integrated IDEs. And so having your workload run remotely then becomes more challenging. Now, there are techniques to actually say do debugging remotely and hook up debugging across some sort of network socket. But that's really finicky to get set up, and you still have the issue of like, how do you do a rebuild without going through an entire container rebuild for this stuff? So I think there, instead of actually syncing the file system, you can find ways to bridge the network, right? So that things running in cluster can maybe call into you, and then you can call into things that are running in cluster also. Telepresence, I believe, is a project that sits in this category. I haven't used it either, so again, it's one of those things I want to cover on TGIK in the future. And then there's the question of like, how do you run this stuff locally? Do you run it in a Minikube? Do you run it in a local container? Do you run it natively? One idea that I don't think anybody has done, maybe I think Jessie might have done this once because she's crazy enough to do that, is could you actually run the kubelet on your local machine and then have it join a remote Kubernetes cluster so that you actually have your own private node that you can muck with, but it's also partially managed by a remote Kubernetes cluster. So that's that. When I say local node, what I mean is attached to remote cluster. That's kind of crazy. I don't know if that would work, but that's I think at least one place in the solution space here. Okay, so you haven't done that, Jessie? She said that would be dope. Yeah, you should totally do that. You're crazy enough to do it. Just make everything more containerized. All right, so that, in my mind, that's the different ways that we can skin this cat. Yeah, so like I think so in terms of TGIK, I think I probably want to do scaffold next week, and then maybe draft or telepresence after that. So yeah, I'm planning these things out a little bit, and I don't think there's a right answer here. I think different techniques here make sense with depending on the tool set and the requirements that you have. Okay, it was Chris that did it. Okay. Yeah, that's right. I seem to remember somebody was telling me they did this, where they ran the kubelet on their local machine, and then did like some crazy SSH tunneling so they could join it to a remote cluster. Yeah, maybe with the virtual kubelet there might be something to be done there also. That might be interesting. All right, so let's start exploring this. So Ksync is in the sync file system thing, which I think is a really interesting thing, and I think it lends itself, I assume, to dynamic languages like Node and Ruby and Python and that type of thing. So, all right. So I spent a lot of time talking, but this, I hope, at least gives us a mental map for how some of these tools fit in to the development process and how they compare against each other. All right. So, let's take a look at Ksync. I haven't used this yet. I've been so busy. I've been meaning to play with it beforehand, but I haven't. So we're going to go ahead and we're going to give this a try. The goal here is to be able to do something equivalent to the Docker run with a -v, where I map my local directory in. And behind the scenes, what Ksync is doing is it's setting up and using this thing called Sync, which is a Go binary, it's written in Go thing for syncing files across a bunch of different computers. It does it with it's I think typically focused on sort of desktop use cases. But I was looking at the code a little bit, and it looks like it might be broken out that you can sort of drive it in more interesting things like this. So I'm really like I wanted to dig in a little bit to see exactly how Ksync was using Sync, but this is the underlying synchronization engine that it's using, and you can think about this in some ways as sort of like a continuous smarter rsync. I think prior art here that folks should be aware of is this thing. So Thomas is saying it has a pretty good API, right? Yeah. So I was looking at it. It looks like it's decently factored. So rewind the clock like maybe a year, and there's this thing called Docker Sync that people. I'm not sure who did this. There was like somebody. This is obviously a passion project for somebody. So that -v that was mentioned in the sync thing, the Ksync sort of thing. It turns out that that's actually pretty slow on Docker, or at least it was. Docker has been doing more and more to actually cache this stuff, and so so people did a whole bunch of stuff. It was especially slow when you're doing things that do a lot of files and stats on a lot of file, which especially describes things like node. And so people did some work to actually create other ways of synchronizing directories across. And so Docker Sync was this tool that, or this setup for being able to do that was really interesting. Behind the scenes, it used this other sync engine called Unison. And this thing is freaking ancient. I was looking at this at one point because I wanted to sort of do a remote Kubernetes build machine, and I kind of got it set up, but it was just a really, really kind of clunky. It was clearly not built to be sort of used in this way. But I think Sync thing definitely looks like it's a more composable solution for being able to do this stuff. So that's really, really exciting. Okay, so Finn says Kubernetes sounds like diabetes. So here's the thing. So we had a big engine all-site for all of Heptio, and one of our engineers, Liz, she likes to pronounce Kubernetes as Kubernetes, like Copernicus, Kubernetes. So from now on, I'm going to try really hard to try and pronounce Kubernetes as Kubernetes, just to really confuse the heck out of people. Or maybe I'll just do it for this episode. So Finn, in honor of you and Liz, I'm going to say Kubernetes from now on, so it doesn't sound like diabetes to you. All right, so I mentioned the scaffold draft and this is telepresence, which were the other ones, but we're looking at Ksync now. Okay, all right, so and it's using sync thing behind the scenes. All right, so now let's go through. It can be as simple as creating a pod and doing stuff, and there's a little demo here, and you can do a katacoda thing, but we want to do it for reals. So the first thing we're doing here is there's a curl to bash going on. Let's actually see what that is doing. And I believe if I look at this, it's saying, hey, you have to be running as root. Or you have to have root access, and it installs it into the target install path is user local bin. And it's assuming that grabbing the latest version and putting in user local bin. So we're not going to do that. Instead, you can grab the latest release here. Let's Ksync Darwin AMD 64. Let's see. What do we got? Downloading that. Kubernetes. I'm going to try. I'm going to try and retrain myself. Man, GitHub sometimes downloading is really slow. Have you all noticed this? But yeah, okay. So that's what we're going to do. So we're going to download that. And then it also knows how to like update itself and upgrade, which is really nice. That's really good to see that. I'm kind of surprised that this thing doesn't, that there's no like brew install, because that tends to be my go-to for this stuff. Will I be posting all the links? Yeah, I'll post all the links. Don't worry about it. That's why I tend to keep like tabs up, and then after the episode, I'll go through and grab all the links from my tabs and goes ahead and do that. And then I also, like, what I'll do is I'll take, like these notes are short enough. I'll probably put these in maybe in a gist there also. All right, and then Thomas says, Ksync has Docker and Kate's clients in it, so the binary is a little porky. Yeah, well, yeah, putting the Kubernetes client in a binary will definitely make it porky, that's for sure. All right, so we have this. We're going to do move to bin ksync chmod. All right, so cool. All right, so now we got the thing. All right, so let's see here. Initialize Ksync and install the server component on your cluster. The server component is a daemon set that provides access to each node's file system. This will also go through a set of pre- and post-flight checks to verify that everything is working correctly. There's also Ksync Doctor. All right, so this will both... Oh, accidentally clicked on that. Sorry. What did I do? I don't know what I clicked on. Did I lose my Ksync? I clicked on issues somehow. All right, well, oh, nah. All right, we'll go back there. There we go. Okay, where are we? All right, so this is the thing that is a little bit confusing to me. Is that, like, number one is that I use kubeconfigs a little bit differently than other folks. I have a directory, a bunch of stuff, and I actually usually set the kubeconfig environment variable to set up. And so I'm hoping that Ksync init will actually pay attention to that environment variable and target the right cluster. And it says initialize Ksync. Well, let's just see what it does. Okay, so Ksync init should work. Let's see. So fetching extra binaries. Ooh, I like this spinner. That's kind of fun. All right, so adding Ksync to the cluster and then waiting for the pods to be healthy. So I have the right permissions and everything. Post-flight checks. Is everything working? Checking the driver on the other side and all that stuff. Okay, so that was pretty easy. I don't see anything in my local directory here, but I think there is a Ksync in my home directory here. So this is something that, like, is pretty persistent. And let's see. There's nothing in the YAML file there. And then what are the other... Okay, and then it pulls down sync thing locally. Let's see. That spinner is the best feature. This is a good... okay, yeah, so we all want to see the spinner. And you totally need to actually integrate lolgopher too. Ask Chris about that. It's our mission to try and get everything fabulous. All right? You guys seen lolgopher? This is something that Chris and I did. It's an output filter that does rainbowness. We need a better image up here, Chris. So yeah, we need lolgopher on there. All right, so that downloaded the sync thing binary itself, and it has a YAML file where we can put some initialization. Okay, let's see. And then you can set up a local client. We can do Ksync watch. All right, and this thing is running on port 40322. Yeah, it's like lolcat's written in Go, but the way we wrote it is that it's an IO writer, so you can chain it in with other IO writers really easy. So that's fun. All right, so okay, so now we have that thing running. And then we have a sample app. So let's see the demo app. But let's sync this so that we can actually like muck with the demo app and see what happens. Right? I probably want to like do a git clone on this. Let's do that. Oh, that was fast. Ksync, cd examples, cd, what is it? You guys are all talking spinners. I want to talk spinners. Okay. Cd app. All right, so here we have, let's see, if I now look here, examples, app. Okay, so what do we have here? So we have a Docker file, which is doing nothing more than like doing a pip install type of thing and then running, doing copy of everything into that directory. App.yaml, this is the YAML for this thing. So pulling down sort of the base image, doing a bunch of stuff. Oh, I like how you do the comments for the ends there. That's actually really nice. That's a good pattern. We have a make file for serving it locally, but then also doing stuff like that. It just requires Flask, and then it's the simplest of web servers. And then VS Code is mad at me because I don't have the right version of Python installed. Okay. All right, cool. So this is like the simplest of Python programs. And if we go ahead and we apply this, let's see. So if we go and we have the app.yaml, this will actually go through and it will pull down the Vapor.io Ksync example container. kubectl apply-f app.yaml. Boom. All right. And we have a service. Oh, fascinating. So you guys did a service with a cluster IP none. So why do we have the service? I don't know. All right. Well, kubectl get pods, kubectl port forward to this thing. All right, so port forward in 1.10, this is actually the best feature of 1.10. I need to find the PR and thank the person that did it. If you specify a service there, it'll just pick one of the pods to the service and actually forward there. Or if you specify a deployment. Now, it won't reattach if you roll the deployment, but at least it means that you don't have to do this dance of like getting pods and then like finding the right pod and copy and pasting it. You can always just go ahead and just port forward to the deployment. So that's actually going to be super cool. That stuff's coming. And then this is port. Yeah, I know, isn't that nice, right? It's like I've been waiting for that forever, right? So, okay, so localhost 8080, and there we go. It's just serving up, I guess, the local JSONifying some stuff, some files and stuff. Okay, super simple. And we can do /demo. Maybe. Oh, it may be running different code. Different code than, because this thing looks like it's crapping out here. What's going on? I'm spinning. Okay, well, we'll have to look at that later. Okay, so, all right, so now, error copying from remote stream to local connection, read from broken pipe. So the server crashed or something. Kubectl get. Oh, it's not running. It's not ready. What's going on? Yeah, so you're doing a headless server. I just wasn't sure why you're running a headless server. Kubectl port forward to resolve service port to target port. Yeah, so 59809. So yeah, that one's really exciting. So why is this not ready? So it looks like it's serving. Was there a ready check on it? Really confused. Ports, readiness probe. Huh. Looks like it's getting, these are all the readiness checks coming through. So why isn't it marked ready? Is it just, it hasn't taken enough time? Let's see what's going on here. Readiness, success, period 10 seconds, timeout 1. So it's looking for port 80, delay 0. That should be working. What's going on? Why is it not ready? Conditions, ready equals false. So for some reason, it's getting a timeout, client timeout exceeded while awaiting headers. This could be some mess up in our cluster setup, but I doubt it. All right, well, I'm not gonna, oh, now it's crapping out here too. Yeah, with no IP, it should default to localhost, I assume. Yeah, port 80 HTTP. Now the whole thing is... All right, something wacky's going on here, and I want to debug this before we actually go any further, because I want to make sure. So the 127 stuff is me hitting it. You can see like the favicon in the demo. And then this other stuff is, these are the readiness checks. So now it's working. Oh. All right, now it says it's ready. I don't know, something wacky was going on there. Caleb says, when you added the new route, did you overwrite the default slash? I haven't edited anything yet, so we're not there yet. So it could be, something should be working. But okay, so we, all right, now we have the thing up and running. Okay, so let's go back to our instructions here. Ready and running, so it's running now. Okay, so now what we can do is we can do Ksync create, and then you create a selector. You say, okay, so all the pods, okay. So we want to create we want to create a mirror between everything in the Ksync directory with the code directory. Okay. It'll take a pod name too. Okay, good. So let's just try this. So we don't have, what I'm going to do is I'm going to do the current directory that we're in, which is the example app, /code there. Okay. So it says, okay, new pod detected. It gave this thing a random name, Strong Rattler. Okay, and so this is, so all that stuff is coming from the sync that's running in the background. Okay, and then the sync is bidirectional. Okay. So I can just do it anywhere. Okay, so now, okay, so now, and if I do .ksync, ksync.yaml. There we actually talk about, okay, so here's the spec of what I want to sync. Here's the local path. Here's the remote path. There's some other parameters there. And so you can do it based on selector, pod, and you can also specify the container name also. And I assume that it probably just does it across all containers in a pod if you don't do something like that. Okay. All right, and there's also a Ksync watch daemon option for full background that logs to a file. Okay, so if you don't want to see the spew, you can go ahead and set that up. So now if I do Ksync get, all right, and this gives me the status of what's going on here. So it's like, okay, here's the name of the sync. Local, it's this directory here. Remote is /code, and we're actively watching it, and here's the pod. So, okay, cool. And then we can do, oh yeah, hey, look at that. We can do, there's the port forward stuff, but we were already doing that. So, Okay, so I don't see anything different there. What are we doing wrong? Oh, we're spinning again. So there's something going on with this setup here. I have to debug that. There's something going on here. I don't like what's going on. There we go. Okay, so now that loaded. And what am I supposed to see? What am I supposed to see? Am I supposed to see curl localhost? So we can do that. We'll do the curl instead of the browser. And open up the code in your favorite editor. Oh wait, what code are we? Oh, okay. So this is. Oh, the M times have been updated. So okay. So what I'm confused about is that like. Okay, so if I do. Maybe I'm a little bit confused on how the layout. I think it might be worthwhile to be a little bit more explicit about what the layout looks like in the target container that we're talking about here. So if I do a kube control get pods, and I do an exec dash ti to this. So let's go ahead. Oh. Okay, so it's an Alpine container because that's why Bash wasn't there, so I did Ash instead. Okay, so this is the thing that I think was missing from the tutorial is that container is set up such that the code that's running is in /code. And so when we start doing the sync, we're essentially overwriting that code. So we're essentially whacking all the stuff that's interesting that gets written in there. And maybe we would see that if we actually looked at the Docker file here because oh yeah, the workdir is /code. So the /code thing, I thought it was maybe /code was relative to the working directory of the thing. So I expected maybe we would see like a /code be underneath it, but no, that's not the case. So okay, so now I should be able to do something like let's see. So if I do, so the demo path is not working because I think it's conflicting with this route. I'm not a huge Flask. Person. So let's go through and do that. And then, lols, Joe was here. All right, we'll do that. Save that. Yes, I know Pylon's not installed. Okay, so now if I go back and I reload this, all right, we see that we actually modified stuff. So that's actually really, really cool. Did you see that? Okay, so I just want to I want everybody to see that again because that's really this is a great development workflow now at this point, right? I can go through here and I can change code. I'm hitting save, tab, reload, and it's updated, right? There's, that is, I think, the holy grail of what we want to have happen is we want people to feel like this thing is running locally from a sort of like save, reload loop type point of view. And so that's super, super cool. So yeah, that's awesome. Now let's see. So, and then you can see here's the watching and it's actually driving an update. So there's some magic going on here between the Ksync watch and the sync thing stuff. It's probably manually triggering a sync thing with the set of files that have changed. I'm guessing you said that this was bidirectional also. The bidirectional thing I'm not so convinced about. I'm not sure that that's a good idea. I mean, I'd love to hear the scenarios, Thomas and Tim, about why bidirectional is a good idea. I think it's not uncommon to have you create a bunch of stuff on the other side that's, local temporary stuff and then copying it back. I'd also be afraid that hey, if I relaunch the container and some of the M times get screwed up, am I going to actually overwrite my local stuff? So that actually would be a little bit confusing. Or if you write a temp file into that directory and you have multiple pods, is it going to go through and sync between all of those things so that now you end up with sort of cross-pollination of state that won't happen when you're in a production environment? So those are things where I'm not quite sure about whether that would be a good idea or not. Okay, so yeah. that's about it. So demo should be there since it's already synced and reloaded. There's a better visualization later on in the demo. Okay, so let's keep going forward a little bit. All right, so we can add a new key. Okay, that's pretty much what I did was like, and then you can do Ksync get to get the status. Watching, so we're all up and running. And you said 10 seconds. I think it was faster than that, so that's really cool. And then you said there's an ignore file. Okay, so if you don't want to sync back, you can do an ignore file. My gut here is that the best way to do this stuff would be to, well, maybe, I mean, the best way is to have it be one way to begin with, to be honest. All right, and then there's a visualization because Sync thing was made to be run as sort of a GUI desktop type of thing. We can go ahead and do this. So now what is this doing? So this is going through. So we're doing the port forward. Okay. Further exploration. So we can scale the app to 2 replicas. Okay, so let's go ahead and do that. All right, and now we're going to be syncing to both of those. And now what is this thing? Frontend.yaml. Let's look at that code. So this is so front end. Okay, so this is a tool to actually introspect what's going on here. Okay. This is a whole nother front end. Look at that. You got like CSS and stuff. Okay, so this was not a sync thing. This was like something that you all wrote. And then for Go, you trigger the build remotely. So the idea is that you copy your Go code up there and then you trigger that and it actually runs inside the container. Or you could exec inside the container, right? And now what happens is like, yeah, that's an interesting idea. Y'all are talking while I'm exploring too. But I did that exec before, so now I'm inside the container. I have a development environment. I can go ahead and create a new file here. And you could probably do a really fancy VS Code integration where you can say, hey, open this thing, a bash there on the other side and stuff like that. But I could go through and do like new file. I could do foo.py, print test. I run this. A bunch of stuff happens. We'll run it in daemon mode. But now and then when I'm inside the container. Now I see, I have foo.py. I can do chmod plus x foo.py. Let's see what happens. Does that actually sync the chmod back? Let's see. I don't know. Yeah. I didn't do the shebang thing, but there you go. So yeah, so this starts feeling like you have like a remote local development environment. That's really cool. And I think the key thing here is that typically, as long as you're just editing code, you're not moving a ton of data back and forth, right? So that's the latency and the incremental update that really, really matters there. And you all are talking about Ksync reloads the remote container for you on file changes. So what do you mean by reloads the remote container? Does that mean like you restart the remote container on file changes? Okay, so let me see. I'm reading through here. For Go or Java, you could sync only the binary artifact produced by a build, but the container would still need to be restarted, right? Because that thing's a root. I mean, you could do something along the lines of having a bash script that kills and restarts it, so that your root of the container, your root process ends up being a bash script that says, I have a new version of the Go binary. Let me go ahead and restart things. So that'd be one way to do it. Okay, it does a Docker restart. So yeah, so if you were doing that interactive bash thing, then you'd go ahead and you would do the Docker restart. So this is super, super cool. I think we got a good idea. I was going to do the visualization stuff. So let's go ahead and do that because I want to see how that works. So we're going to go ahead and we're going to apply that. And then we're going to do all this crappy magic that we have to do the port forward. Oh, not running. Okay, so we got to wait. Get pods. We're downloading some stuff. Let's see, and so Jalal is saying, if a pod has 2 containers, to which container does Ksync connect and sync? and said you configure that in the spec. All right, so while we're talking about this, I'm going to talk about some of the things that I'm not sure if I like or not about Ksync as I've looked at it. So the way that Ksync works is it installs a daemon set. That daemon set runs it with elevated privileges, and it reaches behind Kubernetes backs to understand essentially where things are being stored on disk from a Docker point of view, and it synchronizes there. So it essentially, goes through and is very intertwined with how Docker works and how your cluster is set up, which means that this thing won't work on systems that are using alternative runtimes. It also won't work on systems where you don't have admin to be able to install that daemon set. The fact that it works as a daemon set makes me think that it doesn't work in a multi-tenant cluster in some ways, which means that, remember, one of the whole ideas that we want to be able to do this is because it makes sense to develop remotely when you have remote resources that you need to take advantage of. And a lot of times those things are expensive resources and you want to share them. And so there's questions in my mind of how does Ksync thing works when there's multiple users doing it? Is there a way for me to see code that other people are writing? How hard is the multi-tenancy? What is the security model around that? That's stuff that I would definitely think about. So Thomas says, it would work in multi-tenant clusters. Okay, good. But then there's the question of who's talking to, which Ksync and so that's some of the stuff that I'm trying to. Let's see. You think I missed the and Python in the copy and paste? What did I? Well, these things are running. Yeah, and then I was going to do the bring up the. Oh, I see. And then this thing launches the web browser. Okay, haha. So it just launches the web browser to localhost 8081. Can't be reached. Connection refused. Oh, I didn't read the. Okay, so we're going to do. There we have that running. Okay, now we're doing 8081, and I was just waiting for the thing to spin up. Okay, and this is a React app that is not working. There's zero security model, though, which is fine. I mean, if it's a development cluster and everybody's friends, I mean, that's not an insane way to think about it. But handling connection for 8081. So what's going on here? What is the key combo for the task manager or developer tools? I always forget that because I'm not a web developer. What's going on here? Chrome.load time. So why is this not loading? I'm so confused. Is the script running? It's a React app. And here's the script, but nothing's happening. But I don't see any errors. So demo needs to be updated. Sorry about that. Okay, so is the UI broken right now? Is there something? There's something missing there. All right. So one of the yeah, it looks like it. That's okay. I mean, I think it looks really cool, and I think I'd love to see sort of what kind of information can you get as you start going in there. And so, okay, so this is just going down, tested configurations. So now you can say it's tested on the Heptio AWS Quick Start. So this is AWS with our Quick Start there. We're running, let's see, and I don't know, I think we're running overlay 2 at this point too. All right, and so then there's a lot of documentation. There's some good notes here. I was reading through these on the life cycle of how all this stuff works. This is actually really, really well thought out. I love to see design docs like this. So this is super, super cool. So I've been thinking about this for a while, and so that's why I was really excited to see Ksync come out, because I do think that this unlocks a lot of developer workflows. Obviously, this is a development thing. Ksync init won't let you pass if your cluster is out of spec. Okay, so the overlay 2 stuff. What I'd really like to see happen is, what I was imagining that you could do is that if you're running a pod for development purposes, you could do something along the lines of run a sidecar and then use a shared volume for the thing that you're actually working with. And if you did that, then essentially you're talking one-on-one. It's all user mode. You wouldn't even need cluster admin in any way to be able to talk to the thing. And so that would be perfectly acceptable to run something like that on a production cluster or on a cluster that is shared with harder boundaries, right? You probably don't want to do active development against a production cluster at this point. I'm not sure. It's a different model because there's this idea here of like if we look in, we have the Ksync.yaml that talks about sort of our persistent syncs, right? Then, it'd be really interesting in my mind to be able to say, like, maybe have like a Ksync or something like that file that actually sits at the root of your directory, so that you can boot stuff up and it actually has enough context there that sort of sits with your project for, hey, when you're debugging this project, you add a sidecar and then run Ksync, and maybe there's one parameter which is like the name of the thing to go, and then things work at that point. So that, there's definitely pluses and minuses between this. That wouldn't work with the sort of the many containers as well, and it probably wouldn't be the type of thing where you do the persistent sync back and stuff like that. But I think that would be really, if you're just doing like a one-on-one type of thing, that would be a really interesting way to go. And then the security is it's all user mode, so there's no security concerns around it. So if I were to approach it, that's probably the way that I had been thinking about it. But this is really, really super useful. So let's see. So Thomas says, I got a proof of concept that does that. The downside is that it doesn't work with arbitrary containers. Right. So you'd have to muck with the container in a way so that it's actually ready to be able to do this stuff. We might be able to, like, if you do have cluster admin, you might be able to do something with like a mutating webhook, or and again, this starts getting to the application definition type of things. I could imagine with something like Ksonnet, having a mix-in or some sort of tool that says, and Istio did this when they installed their sidecar, would be like, take your YAML, run it through this thing, and then what comes out the other side is something that's now Ksync compatible. So that's pretty interesting. All right, moving up the stack, that'd be doable with Ksonnet. Yeah, you're way ahead of me there. Okay. Helm is a fig. I'm not going to here's the thing. Here's my thoughts on Helm. So there's some really interesting stuff going on in terms of thinking with Helm 3 that I think solves a lot of the concerns that folks have. I think there's some other interesting decisions going on there, but I'm really excited to see where the Helm folks take things. I think the critical thing to recognize is that, number one, Helm it started a long time ago, and so there's some history going on there. I think the other thing to keep in mind with Helm is that it's solving a very important problem. I think we can quibble with the way that it's being solved, but I think the big value add there is that it is actually solving the problem. But I think this type of thing is one of those examples of if we start looking at, like, how do we break out the application definition from the way that we deploy the application, because right now in Helm those things are really conjoined. So that we can do things like start mixing in things like Ksync, if it did involve running a sidecar. So that's kind of the way that I've been thinking about this with respect to Helm. All right, so I am super, super impressed. I could totally see myself using something like this to do fast iteration. And again, I think it really, really lends itself to dynamic languages like Python. Really, really lends itself to situations where you might be editing static content like HTML, but you have something that's like using that to serve up the rest of what it's doing, and you really want to iterate on that fast in the context of everything else that's going on. So I think that's super, super cool. I think, when you have a build process, I think things start getting a little bit more interesting. How do you actually deal with that build process? I think I don't see... It might be interesting to actually talk about what are the patterns, or how do you make a container that's Ksync friendly, right? which means that, oh, you want to separate your code this way. If you're doing a compiled thing, you want to have, use this sort of rerunner thing that does a kill and a restart based on sort of this file changing, that type of stuff. I think it would definitely be interesting to understand what are the best, mechanisms for being able to start dealing with compiles. Because I think Ruby and Python are still in that mode where there's no compile. Node is just crazy town in terms of like the amount of sort of magic stuff that happens behind the scenes in a dev mode. So it's still doable. And I guess that's another thing is that like if you're doing Node, you want to run, when you run stuff with Node, you generally have like a debug or development profile and a production profile. And so you definitely want to probably be able to run this thing from the get-go using your development profile if you're going to be doing development against it. So my guess is that what we're going to find is that there's going to be a set of tools in this development workflow, and they're going to start specializing to different language and sort of framework stacks, because some of them are going to work better with some over others. So yeah. All right. Well, that I think is a great rundown of Ksync. Really, really cool. And hopefully that's also tees things up to look at some of the other types of tools in this space, figure out where they overlap, pluses and minuses, that type of thing. Any last questions before I go ahead and sign off? I'd love to answer any last things before I say goodbye. But I'm really excited to be back doing TGIK for Kubernetes. Missing 2 weeks, I really missed it. So I'm really looking forward to the rest of this series and covering more of the development workflow tools. So, all right. Well, thank you everybody for watching. I will see you next week, and keep sending me ideas. Let me know what you think of this. And, if you don't already, hit the like and the subscribe button. And I will see you all next week. All right. Thank you so much for watching.